Good morning, all of you.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Morning, sir.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Fine. Okay. I think this is a better. Okay. So,
Good morning, sir.
yeah, good morning. All of you can join your hands. We will start obviously with a prayer. So right now, first I'll share the screen. Okay. See, children, all of you, you will close your, no, you do not close your eyes. You will just join your hands. You can enchant the prayer. There is a meaning also of the prayer given in this. So along with the meaning, you will look at it. We'll start it with the prayer. We had already discussed the prayer the other day. So the same prayer it is. You can just look at the meaning where it goes on.
ॐ सहना भवतु सहनौ भुनक्तु सह वीर्यं करवावहै तेजस्विनावतीतमस्तु मा विद्विषावहै ॐ शान्ति शान्ति सहनौ भुनक्तु सह वीर्यं करवावहै तेजस्विनावतीतमस्तु मा विद्विषावहै ॐ शान्ति शान्ति शान्तिः ॐ सहना भवतु सहनौ भुनक्तु सह वीर्यं करवावहै तेजस्विनावतीतमस्तु मा विद्विषावहै ॐ शान्ति शान्ति शान्तिः
Right. I think almost everyone is in now. We will start the discussion for the day. Children, see now. Right now, for the time being, I'll keep all of you on the mute mode. And again, after some time, I'll unmute you because right now the concepts what I'm going to explain are important. I don't want any disturbances. Okay. So right now, all of you will be on the mute mode. Okay. Right. Fine. So, right. First of all, I hope you have read the meaning of the today's prayer. It's a very nice prayer that we have with us. Such a meaningful prayer it is actually. So it's good. It's good that we both of us together we get the development, the nourishment, and our study becomes effective, energetic. It's good thing. It's good thing for all of us. Now, moving ahead. Today we are going to discuss the word problems depending upon the equations reducible. So last time, in our last session, we had discussed, children, that few equations which are not linear, okay, but we can convert them as linear equations by doing certain assumptions, correct? And if it was the variables were at the denominators, then we assumed them. We assumed them, right? So if it is 2 upon x plus 3 upon y, then we assume is equal to 6. We said let 1 upon x be equal to a, 1 upon y be equal to b. So if 1 upon x is a, 2 upon x becomes 2a, 3 upon y becomes 3b is equal to 6. Equation which was not linear has now become a linear equation in two variables, correct? And then we solved them. Then using that we solved the sums. Now a few word problems, very interesting word problems, very interesting situations wherein we can practically apply the knowledge and try and solve the situations. Okay, now let me first give you a situation, okay, which you can understand it nicely. Okay, suppose this is a plain road, okay, and we all do bicycling, we all do cycling, you all can do the cycling, you all have cycles with you, you do the pedaling. Suppose you are going through this straight road and then there is a hill in between which you have to cross. So suppose now I'm not very good at drawing. I don't know how to draw a cycle also. let me consider this is a person cycling, okay, and he is going. Okay, let us say that the speed of this cycle of your pedaling speed say is 6 meter per second or per second square. Acceleration we will consider it as. Okay, you're going with a speed or an acceleration of 6, force of 6. Okay, and then when you start climbing, will you have to apply the same force or more force? Obviously, when you start climbing, you have to apply a little bit of more force. And in spite of applying more force, see, okay, here, normally when you are traveling, and if you apply a little bit of more force, will you go faster than this or slower than this? Obviously, you will go faster because normal speed was your 6 meter per second square. If you would have applied a little bit of more force, you would have gone by 8 or by 10 meter per second square ka speed. That would be the case if you would have applied more speed. Okay, but here, when you are climbing up the hill, you are applying more force. Though you are applying more force, your speed is reduced. Why? Why? You can see the slope of the hill is downwards, but you are going upwards. You are going against the slope. Means you have to overcome the slope and go. Okay. Suppose the slope of the hill, if I want to give the numbers only, okay, slope is a little bit different, but to make it simple, if I want to give it numbers, suppose the slope of the hill is say 4 meter per second square downwards. Now tell me, by what speed will you be climbing up? Obviously 6 is going up, 4 is coming down. Means you are overcoming this 4 and going. Means out of 6, your 4 is utilized in overcoming the force. Means you will actually travel with a speed of 2 meter per second square only. Suppose your speed was 3 meter per second square and the slope is of 4 and your speed is of 3. Will you ever be able to climb it? No, because your speed is less than the opposite force. सामने वाले का फोर्स ज्यादा है, तुम्हारा फोर्स कम है, तुम उसको यही नहीं कर सकते, उसको पास करके आगे जा ही नहीं सकते. On the contrary, suppose your speed is also 4 and the hill speed is also 4. Now you can climb? No, still you cannot climb. You are right. Why you can't climb? Because equal and opposite forces, they will cancel out, nullify. Means you will keep on paddling, but you will stay there. Because equal and opposite force. The moment you overcome this, the moment 4 becomes 4.1 or 4.2 or 5 or 6, then the opposite force is overcome and you have started moving up. Correct? So that is why the rider's force always has to be greater than the slope. That we can understand. This is simple general knowledge. So while going up, it was 6 minus 4, net force was 2. So heaping and howling and trying, doing all the efforts, you reach till here. Now you are here. And now you have to come down. Now what will happen? Now do you have to apply more force? No. You just release yourself. Automatically you are going to come down. You know that. Why? Now, because this slope is going to help you. You know that your cycle is automatically going to come down the slope. Again, we know the slope is of 4 meter per second. Correct? And still you feel like that a lot of time was wasted, or I have to cope up with the time because while coming up I needed more time. So again you apply your normal speed. That I can do easily. I don't have to worry much because that is my normal speed. You are also applying the speed of 6. Hill is helping you with the speed of 4. So now while coming down, what would be your net speed? Actually, it would be 10 meter per second. Because the 6 of yours plus 4 given by the hill. Simple thing it is. So while going up, it would be 6 minus 4 speed of the cycle minus the opposite speed of the slope. But while coming down, speed of the cycle and speed of the slope both are downwards. So that would be added. This is a simple and basic thing. Same thing, same concept. Now we will apply in the case of water stream. Now I will draw the thing. Suppose there is a water stream. There are different words. Also, they call it as water current. Sometimes means what the force of the water, the speed of the water. Suppose there is a boat, and here you are doing paddling. When you do this for the boat, it is called as rowing. You know these words, R-O-W-I-N-G, rowing of the boat. Correct? So now suppose you are rowing. Now, again, let the speed of your boat, now, important points. In these cases, we know one formula, speed is equal to distance upon time. Since 7th standard, 8th standard, we are learning this formula, speed, and it should be there in your brains. Whenever the question comes about speed, speed of boat, speed of train, speed of bus, speed is equal to distance upon time. Speed is equal to distance upon time. That is a general formula we all know to calculate the speed. Speed is equal to distance upon time. Here, very important, the distance should always be in kilometers. Time should always be in hours. And that is why we generally say, आमच्या गाडीचं speed 100 km per hour. 100 चं speed आहे. 80 चं speed आहे. Means what? It is 100. You look at the odometer, speedometers of your cars. You will understand that 100 kilometers per hour, or sometimes kmph is written on our speedometers. 0. If you have a digital, then no issues. But if you have an analog one, then it would be 0 over here, and this hand moves until here something there is 240, 264. Nowadays cars, whatever you have with you, nowadays the cars which you have with you, and then your hand goes on increasing, okay, and you feel the thrill of the speed, but that speed is always in kilometers per hour. That means so many kilometers in 1 hour. It is always per hour. So we always take time in hours, distance in kilometers. Very important. Few little things you will keep it in your mind. If the time is not in hours, we will convert it into hours. Correct? Suppose the speed of your boat is x kilometers per hour, and speed of the water current. Water is also flowing downwards because it is a downslope. We call this as downstream. Just as we called uphill and downhill, likewise downstream and upstream. Now, when you are rowing downwards, what will happen? Suppose the speed of water is y kilometers per hour, because these are the two unknown quantities, x and y. So now, when you are going down, what will be your speed? Speed of boat plus the speed of water, because water is assisting you, water is also flowing down, you are also going down, both are coming down, the speed got added. So here, while going down, your speed would be x plus y, correct? Because your speed is assisted with the speed of the water. But when you are coming up, जब उल्टा आना है, water is going like this, but you have to row upwards. In that case, what will happen? You have to overcome. You have to go upwards. Hill was downwards. You have to overcome. So in that case, speed while traveling upwards will always be x minus y. Am I clear? This is the basic important point. Why? And this question always comes into the exams. Always for grade 10 exam they will ask this. So while rowing downwards, speed would be x plus y. While rowing upwards, speed would be x minus y. Okay, so very quickly we'll move to the word problems. This is question number 2, first question. So now let me read the question. So they are saying Ritu can row downstream 20 kilometers in 2 hours. So now again it is about a stream. She is going downwards. Okay, they have given distance, they have given time, and we know speed is x plus y while going down, and upstream 4 kilometers in 2 hours. Find her speed of rowing in still water and the speed of current. So always we know that rowing speed would be x kilometer per hour. Just as I shown you, your normal speed was 6. That's why similarly in the still water, if she is doing the rowing of the boat, normally she can go by a speed of x. So while going down, x plus y, while coming up, x minus y. So all of you quickly draw the figure, show a little bit of down. So this is question number 2, first word problem. Show this and then show this water current. It is also called as water stream. You should know all these words. Water current, y kilometers per hour. Write down all of you. Just writing here some words for myself. Don't write this. Just draw the figure. I'll tell you what is to be written. Just draw the figure. So write down. I'm just having a quick look at the number of participants. Is everybody present? Yeah, so write down. Let the speed of the boat in still water be x kilometers per hour and the speed of the water current be y kilometers per hour. Therefore, now this is therefore, this is not there in your given part. While rowing downstream, speed is equal to x plus y kilometers per hour, and while rowing upstream, speed is equal to x minus y kilometers per hour. So now, case 1, case 2. What is case 1? Rowing downstream. Case 2, rowing upstream. While rowing downstream, Sujay, I am unmuting you. You unmute yourself. Wait a minute. I will unmute you first. Sujay, unmute yourself.
Yes, sir.
While rowing downstream, what is the speed?
X plus Y.
They have given 20 kilometers downstream in 2 hours. So what is the distance?
20 kilometers.
And what is the time?
2 hours.
While rowing upstream, how much is the speed?
X minus Y.
How much is the distance? They have told
20
4 kilometers
kilometers.
up. Okay, how many?
4 kilometers.
And time?
2 hours.
2 hours. We know that. What do we know, Sujay?
Speed is equal to distance upon time.
Very good. Speed is equal to distance upon time. I will erase this part. So now tell me, for case 1, what should I write? What is speed?
Speed X plus Y. X plus
So,
Y.
X plus Y is equal to
20 upon 2.
therefore
X plus Y is equal to 10.
equation 1. For case 2,
X minus Y is equal to 4 by 2.
therefore
X minus Y is equal to 2.
what can we do now? Simple equations we have got. Very, very simple equations. What to do?
We can add. We can add.
Correct. So adding equation 1 and 2. Tell me.
2x is equal to 12.
Plus y minus y gets cancelled. 2x is equal to 12. Therefore,
X is equal to 6
what 6? Okay, right now we'll write just a bracket for 6.
kilometer.
And then what? Using,
First equation.
tell me the equation. X plus y equal to 10. So what should I write?
6 plus y. 6 plus y is equal to 10.
Therefore,
Y is equal to 10 minus 6.
y is
Y is
equal
equal to 4.
Oh, we have got the same answers what we were discussing. So what are we going to write? Therefore, final answer statement.
The speed of the boat while rowing downwards is 6 kilometers per hour.
No,
And
not
while
while going
rowing upwards,
downwards. Sujay, no. What is x? X is just the speed of the boat. And y was speed of the water.
yes,
So while going down, how much will be the speed?
10 kilometers. 6 plus 4.
But 6 plus, but they have not asked us that. Actually, they have not asked us speed of going down and speed of coming up. Okay.
Yes, sir.
See, and still, let us understand. Suppose while going down, 6 plus 4, 10. 10 kilometers in 1 hour. So how many kilometers in 2 hours?
20.
That is what they had given us. 20 kilometers in 2 hours. While coming up,
Yes, sir.
6 minus 4, 2. 2 kilometers in 1 hour. How many kilometers in 2 hours? 4.
4 kilometers.
Means our answer is verified. But what was x? Speed of boat. Therefore, speed of boat in still water means normal speed of boat, not down, not up, normal speed. Speed of boat in still water, this is what we had assumed, is equal to 6 kilometers per hour, and speed of water current is equal to 4 kilometers per hour. Am I right?
Yes.
Yes, good. Very good. So this is our question number 1. Yeah. All are finished. Question number 2, again an important question. Pay attention, all of us. Now, Before I begin the question number 2, again, a little bit of explanation about all these things. Very important question. Again, very, very important question. Question number 2. Now, I will draw a figure for you. Okay, and I do this shading. If I ask you what is this, what will be your answer? 1/6. Because this is one fraction, one part out of 6 equal parts of the whole. We have divided this whole rectangle into 6 parts and one part I have shaded. Am I right? Similarly, consider the same thing for doing a particular work. In our case, it is about doing an embroidery work. Suppose this much of embroidery work is to be done on a piece of cloth. Okay? And suppose I am working on it alone. I need 6 days. Why 6 days? Because on one day I will do this much, second day this much, third day this much, fourth day, fifth day, and 6th day. This is how I am going to work. Just a moment, children. Much. So, suppose I was going to need 6 days to complete this work. Then in one day, I will complete one part, means 1 out of 6. In 2 days, obviously second day I will do this much part. So in one day, I'll complete 1/6. In 2 days, I will complete 2/6. 3 days, 3/6. That is half the work gets completed in 3 days. 4 days, 4/6. 5 days, 5/6. In 6 days, 6/6, that is one complete work. Full work will get completed. Similarly, so now they will ask me how many days are required. I don't know how many days. Here I knew it's 6 days. So I will say X days. So if X days, if 6 days were required to complete the work, understand, listen very carefully. If 6 days were required to complete the work, then in one day, we could finish 1/6 of the work. Similarly, I'm writing here, if 6 days, then in one day, 1/6. Similarly, if X days are required, then in one day, how much work we can do? 1/X. When 6 days were required, in one day we could do 1/6. So if X days are required, in one day we will do 1/X work. Here it is fine. Now, suppose I want to do this work faster. Okay, and I take the help of someone. Suppose somebody say Zubair is going to help me. Okay, so I start working from here and Zubair starts working from this side. So one person, if I alone would have worked for one day, I would have done 1/6 of the part. But we both have worked together. One person could do 1/6. 2 persons could do 2/6. Just as in 2 days I would have done the work, but now one person has done 1/6. So 2 persons can do 2/6 part of the work. Similarly, if X days are required for one person, then in one day, one person will do 1/X. 2 persons or 2 people can do 2 upon x. 3 people can do 3 upon x and so on. So when this also question always comes in the exam about the work done and number of days required. Number of days required. And we will always write number of days required as x. And we'll convert it for the 1 day's work. If x days are required, then in 1 day, 1 person can do 1 upon x. So 2 persons can do 2 upon x. Are we understanding this part? All of us? Just give me the reactions if you have understood this. No need to speak, just give me the reactions in the reaction box if you are understanding this part, all of us. Good. Fine, fine, fine. Very good. Okay. Very nice. Okay, I will continue now the part. So let me read the question. See what they're saying. 2 women and 5 men can together finish an embroidery work in 4 days, while 3 women and 6 men can finish it in 3 days. Find the time taken by 1 woman alone to finish the work, and also the time taken by 1 man alone. Just now I told. For 1 person, x days. What will say? For 1 woman, x days. So in 1 day, 1 woman will do 1 upon x. In first case, 2 women are working. So 2 women will do 2 upon x. Again, this is for 1 woman. Similarly, we'll say y days for 1 man alone. So then 1 man needs y days. So in 1 day, he will do how much? 1 upon y. In first case, 5 men are working. So 5 men will do 5 upon y. This is the work of 1 day. And again, these 2 people together, men and women, 7 people together can finish the work in 4 days. Then 7 people on 1 day will do 1/4 because they are finishing the work in 4 days. All 7 are working together and they need 4 days. Which all 7 together in 1 day will complete 1/4. Second day, they will complete another 1/4. Third day, another 1/4. And fourth day, another 1/4 to complete the entire work. Which all 7 working together. If they complete it in 4 days, so all 7 in 1 day can complete 1/4. Here, that's what we are going to write. Let me see how much time is left. Hardly 1.5 minutes is left. We will do one thing. If the meeting gets over very quickly, we all will rejoin. We will finish this sum and then take a break. Okay? Because again, the second lecture is also mine only. So we just finish off this lecture and then take a break. Start writing. The sum is about number of days required by 1 woman alone and 1 man alone. It is always like that. Woman and man, man and boy, boy and girl, woman and girl. So 1 person will need X, another type of person will need Y days. So write down. Let 1 woman alone need X days to complete the work. While 1 man alone need Y days to complete the work alone.